All right, so at this point, we've recalculated low. Let me go back to my camera. All right, make sure we can see everything. So we've recalculated low, and now it's a 5. And then, so we've done the if else, and then every time through, we're going to recalculate middle. So the new low is 5. The high, which did not change, is 8. So 5 plus 8 is 13, divided by 2, and using Java math, is 6. So that's middle. So now what we're going to do is, let's go back and see, how did this change my picture? Okay, so I've got a low of 5. So this is no longer true. This is no longer true. Here's the new low. Here's the new middle. And high did not change. So and at this point, that's the end of the while loop. I'm getting ready to go back up to the top and start the while loop again. But here I want to pause. What just happened? What just happened is that I was looking for 7. What did I do? I compared it to the middle value. And I checked, is 7 less than 4? It was not. So that must mean it's to the right. Since everything's in order, if 7 is not less than this middle number, that means it's got to be over here. So what did we do? We threw away everything to the left of the middle, because basically we don't need it anymore. And that's the beauty of the binary search, is that every time we go through this, we're going to end up throwing away essentially half of whatever's left in the array until we get the answer that we're looking for. So at this point, it's like we've thrown all this away. It doesn't exist anymore. So I'm going to just cross it out. So this is our new array that we're working with. So now we go back up. Now we're looking for, so I'm going to cross that out, cross these numbers. Oh, 7 isn't going to change. Low is now 5. And key is, this is going to change. This is going to change, and so on. I know it's a little confusing. So now numbers of middle, remember what middle is? 6, right? So numbers of 6 is what value? 6, lovely. Just what we didn't want, but that's okay. So is 6 not equal to 7? Yeah. And is low less than high? It is. So I go inside. So is 7 less than numbers of 6? Is 7 less than 6? No. So I do the else, which is a recalculation of low. So now low equals the current middle, and the current middle is 6. So this is going to be 6 plus 1 is 7. So that's our new low. And then our middle becomes, I'm going to cross this out, 7 plus the high of 8 is 15, divided by 2 is 7. Okay, so now we're going to go back up. Low is 7. This becomes 7. I'll write it underneath this time. High is still 8. 7 is less than 8. Now we're looking at numbers of middle, but middle is 7. So we're looking for numbers of 7. And what is numbers of 7? 7. And key is 7. So what happens with this while loop? Is this a true statement anymore? No. And remember, you have false and true. And for an and statement, they both have to be true. So we're done with the while loop. We're done with the while loop. So now we come down here. If numbers of middle equals key, is that true?
Yes.
Does 7 equal 7?
Yes.
It does. So guess what we're going to return?
7.
7. How long did that just take us? A bit of time, yeah?
I'm just curious. It's kind of confusing since the array is 7, the array spot is 7, and the number inside is 7. But when you return middle, let's say the array spot was 6, you would return still 7. You would return the number inside of the.
No, you always return the index value. Okay. I didn't do that on purpose. I kind of wish they wouldn't have lined up like that. So now let's go to our code and let's test this. I want you to see it working in action. So the first thing that's required is that we take our array and we sort it. So let's make a new array. Uh-oh. And I'll call it Y, just like I did in my picture, with an initializer list, 1, 2, 3, 4, 4, 5, 6, 7, and 9. Make sure it compiles. This time we're going to go int, bind, find, bind for binary, find 7 equals. To call that, we're going to say searches, binary search. We're sending it this time Y and 7. And then we're going to steal the SOP from above. And find 7. Okay, so we got the answer we were looking for. So let's copy this and look for 8 just to confirm that if we don't find what we're looking for, that it will give us a -1. And are there any questions about that? Because I want to take a minute to just think about what's going to happen here out loud with our code if we're looking for 8. So it returns a -1. Let's look at the code though. Let me tell you where it kind of falls apart. So every time, if we were looking for 8, we know that it would happen on this side of the array, right? Does everybody agree with that? So if we were looking for 8, we would go through this process until this happened. Eventually, low would equal high, because what's happening every time we're going through this is every time we go through, this thing is cutting itself in half. Until eventually, low would be equal to high, or low would be bigger than high. Then this would go false, and then we'd come down here. So if we're looking for 8, numbers of whatever middle was the last time through, does it equal 7? That answer would be no, and that's why we would return -1. So we keep taking this thing and cutting it down all the way till it's basically down to 1 element. Does that make sense? All right, very good. So you can imagine that one of your first assignments in here is going to be to write a linear search and a binary search for a string array. And that's your homework for tonight. I want you to, so I'm going to make it a Google Classroom assignment. You're going to code binary and linear search, and this time the array will be a string. I'm going to give you the choice. Actually, let's do it on paper, because I don't want people to be like staying up half the night. Let's do this on paper. Remember, strings are different, right? Integers, we can use equal signs and double equal signs, but for strings we cannot. How do we check for string equality? Dot equals. Very good. A string key. So instead of an int key, you're looking for a string